So what is electric circuit? An electric circuit is a path in which electrons from a voltage or current source flow. Electric current flows in a closed path called an electric circuit. The point where those electrons enter an electrical circuit is called the source of the electrons. So this is the circuit diagram representation over here for electric circuit, and this is the pictorial circuit diagram representation. You can find a switch over here and a bulb and a battery, which is actually a closed loop. You can find a closed loop. So this is one such example for electric circuit. We shall see even more about the electric circuit. So here you can see how the charges and the current is getting to be transferred. So based on the current flow in the electric circuit, you can find a bulb which is, so this is a battery. So this is the internal structure of the battery where we can find the negative and positive ions. This is the graphic rod which is actually having the positive and negative charges, and this is the negative electrode, and this is considered to be the positive electrode. So positive and negative, which is a kind of closed loop. You can find the closed loop over here where we can able to see the transfer of positive and negative charges. So these things are happening in a closed path of the electric circuit. It is clearly observed how the positive and negative charges of the current electricity is working. So based on the configuration of electric circuit, the electric bulb is getting to be glow. So this is the example depiction of the electric circuit. Now let us see some examples of electric circuits. Here you can find different types of electric wires. So this one is considered to be a single conductor wire, which is a solid core wire, and this one is the standard wire, and these are nothing but the multi-conductor cables. You can see here the multi-conductor cable. It is actually having a type specification of Nm. Nm is nothing but the non-metallic sheathed one, and the cable inches has been specified over here, and this is considered to be the other type of Nm, which is actually having a different cable specification. And for the interior circuits, it contains two hot wires. You can find over here, and its properties of having the neutral wire, grounding wire, and the hot wires. And this is considered to be the large applicable cable, large appliance cable, which is of having a volt of 120/140 volt, and this is the type of MC armored cable, which is mainly used for interior circuits only. So this is the layer which is stated as spiral metal armor, and this is the plastic wrap. Other such common examples of electric devices are electric motors and electric light. Let's talk about voltage. Voltage is like electrical pressure that pushes and pulls charge. Voltage difference is nothing but the push-pull that causes charges to move, and it is measured in volts, which is represented as V. Voltage is a measure of electric potential energy. Apart from that, voltage is also measured in volts. The representation is V as well. The voltage difference of 1 volt means 1 ampere of current. That is, 1 ampere of current does 1 joule of work in 1 second. You can see an example of how to measure the voltage. So you can find the voltage pressure and which is causing the current to flow in electric circuit and which makes the bulb to glow. So this is the interior functionality of how the electric circuit will work on. Now let's see about resistance. So what is resistance? Resistance is nothing but the tendency for a material to oppose the flow of electrons. Resistance tends to change electrical energy into thermal energy and light. The example is light bulb filament. You can see the light bulb filament. And resistance is measured in ohms. The symbol for ohms will be represented in this manner. The voltage V across the resistor is proportional to the current I, that is I, that flows through it. So, in general, resistance does not depend on the voltage. We have the formula specification stating as V equal to I into R. V is voltage, I is current and R is resistance. Other than that, resistance depends on type of material, size and shape, temperature. L is specified as length of the wire, A is nothing but cross-sectional area, and this representation of resistivity will be in this manner, which will inherent to material. You can see a depiction over here. So this is the area and this is the length and this is the resistivity. So in order to find the resistance, we can find by using the formula specification which is mentioned over here. Let's talk about the factors which will affect resistance. So these are the factors that affects resistance. The first one is length, the second one is cross-sectional area, and the third one is material, and the final one is temperature. If you consider the factor length, it is actually having less resistance. In terms of cross-sectional area, you can find how the less resistance and greater resistance will have an impact on these factors. In terms of material, for copper we have less resistance, and in terms of aluminium we have greater resistance. Now let's talk about control flow. A voltage difference causes the charges to flow. Flow of charge or control charge, we can also tell it as control flow. So the flow of charge is equals to current, that is measured in amps or stated as A. And also electrical resistance restricts the movement of charges. You can see the concept of how the control flow is all about specifying for resistance, current, pressure and current. So this is the voltage difference. Resistance equals to current and pressure equals to current. But the voltage difference will be, for resistance, you can able to find the increase and decrease. Sometimes we can find the charge which is increasing. Sometimes you can find the charge which is decreasing. That is nothing but we are emphasizing for the restriction of electrical resistance, which is considered to be the movement of charges. So this is the overall representation of how the electron flow will be.